Hello and welcome everyone. So I'll be explaining you problem C of Codeforces recent round 696 div 2, problem named array destruction. This was actually a brute force type problem. Okay, we actually needed a special STL multiset. I will show you how we will deal with it. So let's jump into the statement. So the statement says that, okay, you're going to be given an array of 2 n positive integers, okay, 2 times n positive integers, and in the beginning you select any positive integer x, any. Then you have to do the following operations n times. Okay, so in that n times you would select two elements with the sum equals to x. Okay, you would select two elements from that array where the sum of that two elements would be equal to the initial first value, x. Okay, so sorry for the background sound. um, so please ignore it. Okay, so let's select we're going to be selecting two elements of the array with sum equal x. This is for initial x. Okay, the initial x here, they also say that the initial x that you're going to be selecting, that will be random. Okay, that will be your choice, but after that you would have to remove them from a and replace the this x with a maximum of that two numbers, which means firstly when you select an x, that would be totally random. Okay, but for the next things, okay, when you jump over for the next operations, then you have to select x from the selected two values that you selected from that array. You have to select the maximum one of those two. So let's take one example here. I hope you will understand better. Let's take one example here. Let's take the bigger one here. 1 2 3 4. And one thing to notice is that we will sort the array, and I will show you, show you why is we have to sort the array. And we also need to use multiset and STL library. Okay, you have to also use this. I actually used to solve this, and the total complexity of the problem will be n square log n, you could say. Okay, n square log n would be the complexity. And let's take a very good example. This last example here is a very good example. Let's take a look at it now. Okay, so we've got 10 elements. Okay, 5 times 2 means 10, and we're having 1 2 3 3 4 5. Okay, 1 2 3 3 4 5 6 7 and 11 and 14. Okay, and 7 and then 11 and what, 14. So 1 2 3 4 5 6 7 8 9 and 10. So these 10 elements I have. Normally what we have to do, we say that the initial x that we're going to be selecting is our own choice of random value. Now also we need to care about that, take care of that, whether we could whether we could, I mean, throw out all the elements of the array. Otherwise it's gonna be no, which means there won't be any possibilities that I can throw out all the elements of the array. So if it does not require that, I mean, if it does not meet the condition, then the answer could be no. But if the answer is yes, I also have to mention which of the two values that I worked with in each of the steps. Look here, let's say here also I have to print the initial x meaning by the first x that I'm going to be taking, which is the random x that I'm going to be taking. Okay, so here what we also have to print is, after printing yes, we also have to print that initial x, and also each and every step that we take and remove and erase two values, we also have to mention them. Okay, we also have to mention those two values for which we were taking our operations and making sure that this is the possible optimal way to erase. Those two values we have to print. Okay, now let's just take you and let's just explain you by this example. Okay, now actually the first or the initial x that you're going to be taking, you always have to, okay, you always have to be uh, I mean you always have to be careful about that, is that always there will be one value, okay, which is going to be always the maximum one. Now, for when you initially when you select an x and do the random operation and do apply the random x, okay, that one of the elements, okay, this random x will be addition of two numbers. Initial, I'm talking about the initial x, okay? The initial x that you're going to be dealing with is only going to be the addition of two numbers, right? Because in the step we also say that we will always take care of an x and we'll go by step. Now, uh, so the initial, so the step, so the main part, so the first step is that when you take the initial x, one of the values will always be the maximum one, okay, the maximum value of the array, okay, that we are given. So here the maximum is 14. I'm putting here 14. Okay, now always one of the values for the initial x, always one of the values will be the maximum, because if it does not become, or if we do not put the maximum value, then we can never erase all the elements of the array. It is obvious, because you cannot make them, you cannot make anyhow, you cannot make that big element, you cannot erase that big element with that, because each time what you are doing, you are actually taking the maximum of those two values that you are taking, and then addition takes up to the value x. Okay, so one of the values, so for initial x, one of the values will definitely be the maximum value, and here we have to do a brute force operations, because one of the values is maximum. Okay, we have got that, covered. But for the another value, we have to take we have to traverse all the values from the last to the first. Okay, so this is the thing that we need to care about. One of the, for initial x, one of the values will always be the maximum one, and the other values we have to traverse for each and every possibilities of random. So our initial random cases, or initial random x, okay, initial x that I'm gonna be guessing will have total or at most of n. Okay, so I will check for at most of n my initial random x, where one of them will definitely or always be the maximum, and the another of them will be from these values, the rest of them. And I will check which of the, for if any of those if any of those values, I'm gonna check each time, and traversing each time I'm gonna take any of those values, and let's say uh, for this case, let's say we're gonna be, or I'm gonna be taking this 7, and I'm putting here I took 7, so this was my first assumptions. And now for each time, remember, I will do this for each and every value. Okay, now let's assume that by traversing we have come to this portion, this value. Now I'm gonna take this value here, and my initial x, this is my one of the possible initial x, would be what, 21. Okay, now what we said, we will determine at most n initial x, and then for each of those initial random x we will determine, okay, what can we make uh, or can we just throw out all the elements by taking this initial x? That's exactly what we're going to be doing. Okay, so for at most n initial random x, by taking like this, where one of them will be the maximum value and another one will be out of those n minus 1 values, we will check for each and every, remember I'm repeating again, for each and every random value x, my initial random x, I will check whether if I take this x, then whether I can make other steps to make the rest of the values what uh, vanish. Okay, so I will check whether I could make or I could throw out all the values by taking that initial x. So this will be my first loop. Inside the first loop I'm going to be taking, and inside the second loop my multiset is going to do the work to make sure that I am doing the same thing. Now how is the task going to be happening inside the multiset part? So I've told you the step 1. Now I'm going to be running out for the step 2. Okay, now let's take this example again and try to understand. Now first of all, I have to clarify you one thing, that what is a multiset? A multiset is actually an STL. Okay, this is kind of like set, but the difference is that multiset takes repeated values too, whereas set does not take. Assume that I'm inserting 5 3 3 minus 1 in inside a multiset, then the multiset would contain values like this. Okay, 3 and then 5. Okay, minus 1 3 3 5. Okay, so that's and in terms of set, it will just take this. Okay, now also you need to understand, you need to know that inside multiset or set we can do erase operation. Okay, we can do erase operation here inside multiset. We can do, and we can also erase a particular value from our given set, and we could erase that. We could find it whether it is or not. Okay, and we could also we would also do this sort of operations here. Okay, find and erase, this will definitely help us. I'll show you in the code too, but let's just draw and try to understand how the solution actually works by drawing the same example here. Now 5. Okay, so here 1 2, let's say 1 2 3 3 4 5 6 7 11 and 14, right? Okay, now I will just show you a solution for which I can get an answer, which means I can get an yes. Okay, a yes. So for a yes answer, I'll show you the optimal way, but I will always do and traverse. So the optimal way is that if I take 14, 14 will always be, okay, 14 will always be one of the random initial values, but this will be, I have to check for the brute force approach, I have to check for each and every values. But for the yes answer, I actually found out that the last answer that they gave was actually, what I took the values here was 7 and 14. This was our initial value, and our initial guess would uh, and our initial guess would also be 21. Okay, which means 14 plus 7 actually. So this has to be our initial. For the optimal answer, I'm just showing you the optimal answer solution. So for that, our initial random guess x is 21. Okay, let's assume that x is 21, that I have selected x as 21. Now what can I do? Now look, x is equal to 21, right? And so we will do like this. Okay, now 14, I know that 14 will be one of them. So 7, so if my initial guess is 21, then 21 minus 14 is 7. Now this 14 and 7 will be my first step operation. Now what will happen in the second step? As the instruction said, you have to erase these two values and take your x as the maximum of those two erasing values. Now tell me, now let's so what will be the next x? The maximum of 7 and 14. So this is our maximum. Okay, now what will we do next, and how will we choose our next two elements? Now how should you do that? Now look, what we choose, what was our previous x? Our previous x was 21, and our new x is what? 14. Now what we have to do here is, look, I will traverse what? From the largest to the smallest. What is there? There is a value. From when I will traverse, I will check the last element, which is the greater one, obviously, because I'm taking inside a multiset, and the last value inside that multiset is 11, right? Now what we have to do is we have to make sure that as this is the maximum, I will try to find out whether this maximum has some, this maximum value can be uh, created from the rest of the values. How am I going to check that? There's a trick to check that here. I can check this using by allowing and by doing the subtraction operation between our last x value, which was what? 14. Now what will I do here is 14 minus 11. What is that? 14 minus 11 is 3, right? What does this mean? I told you when for I'm telling you again, okay? Now let's take when you took x equal to 21, what you decided? Well, you decided that how am I gonna make 21, man? You're gonna make 21 by how? 7 plus 14, okay? And then you're gonna be taking the new x. What was the new x? It was 14. Now how are you gonna be making 14? You're gonna be making 14 by how? If you subtract 14, if you subtract 14, if you allow the subtract operation of 14 minus 11, what does come? The term that comes is 3. Now if you look at, is 3 available in my multiset? Yes, it is. So you could make 14 by, how can you make it? 11 plus 3 equal to 14, right? So 11 plus 3 is equal to 14, which means I've got another pair of integers where that sum is equal to the x, and that's exactly how you're going to be traversing. I'll show you how the next steps go. Now 11 plus 3 equal to 14, right? Now what will be our next x? Our next x will definitely be the maximum between 3 and 11, which is what? 11. And then you're going to be what? Deleting or erasing these two operations, 3 and 11. So I also have to track which are the two different integers that I'm taking care of, and I'm doing the operations. I have to take them inside my vector, which I have to also give an answer if I fulfill and throw out all the elements, right? So what you have to do here, then okay, let's go to the next part. Okay, so we erased 11 and 3, and how can we make 11 now from the rest of the values that I have, or I have available? How can you make? Okay, I'm finding out. Okay, there is 6. Okay, now if I do subtract operations of 11 and 6, what will I get? I will get 5. Is 5 available in the multiset? Yes, it is. Here it is. It is available in the multiset. And what you have to do now? Okay, I've got my 5, which means 11 can be made using the additional operation of 6 plus 5, right? Is 11. So my new x will be what? The maximum between 5 and 6. Also, my new x is now 6. And I'm also going to be what? Erasing those values. And what about next? Next, we also have to take care of how did I make x. I will also check how did I make x. Is there any way to make x? I will check out, okay, let's check out my maximum available maximum inside the multiset. Okay, there is 4. Now 6 minus 4 is 2. Is 2 available? Yes, it is available. It is available. So I can also make a pair of 4 plus 2, which equals to my x. So I can also erase these two values of 2 and 4. So what will be my next x then? The maximum between 2 and 4. What is it? It is 4. And so we have got our x. Now I will also try to understand, how is there any possibilities, or is there any elements left for which I can make x by adding two elements? Yes, there is. Which are they? They are 1 and 3. So you have to add 1 and 3, and you will find out what is the value. What? 4. So by doing that, we have also what? Deleted these two values. Now, how is there any elements left? No, there are no elements, which means it is that we have got one optimal answer. And there might be a case where you would not get for any kind of random initial x, you would not get your answer. You might not get your answer. You might not found the value inside the multiset. I mean, you could not have found. In some cases, it might happen that you may not found inside the multiset, I mean, the value you're looking for. Then the answer would be no, and you have to check for each and every n minus 1 elements apart from the maximum one, which is going to be the last one, which will always be a part of the our initial random x, right? So this is how you're going to be solving. So let's take you to the code part here. Make sure you know everything about multiset here. Okay, so it's gonna help. You can check out Geeks for Geeks or other website, or Google about it, so that you could learn more about this sort of STL. It helps a lot. Now look, what you have to do is you're gonna be defining a multiset and also a vector. This vector is actually for the result that we're gonna be printing, which of the values that we actually took and worked for each and every kind of step, if we could throw out all the elements, right? So here we took t and took n equal to n minus 2, because we're going to be working on with 2n elements, right? 2 times n elements. And initially what we have to do is we're going to be taking all the elements and also taking them inside the multiset, and after that also sorting the elements, which is very much needed. We have to sort the elements here, and we will sort the elements here, okay? And after that we have to do is initial x. So our initial x, what we have to do, okay, so this is actually we already know that we will somehow find x, right? That's why I'm actually assigning our x as an, because I actually know that there may be any possibilities that I might get our x, right? Initial x, and this is for this double x is actually the value that I have to print. So this double x is our initial first guess that we could always find. That's why I am actually I am here assigning here, if I somehow find out that yes, I can throw out all the elements, then I would just print here double x. That's why it's here, and this x is actually for the next part. Actually, I actually did the both work at the same time. I actually figured out, I mean, I actually did two works at the same time here. The first up, I actually did both of the operations, to be honest. Now look, we will initially what, erasing the elements. I'm just defining and just assuming that, okay, for each and every time I'm going to be assuming that, erasing the last elements and the element that is not the last. And that's how we will begin our story, right? The steps. And inside that multiset, this is the fun part. inside the multiset, what we have to do here. Now this part is actually referring to the last element of our multiset. Again, I'm telling you, this is actually pointer, and this s.r begin is actually referring to the address of the last element, and this pointer is actually referring to the value. Again, you will understand more when you learn about multiset. This thing is nothing but referring to the last element of our multiset yet. Okay, now what we said that we will check. No, what is this line referring? This line is actually referring that, okay, what was our initial x and what is our last value, which means what is our maximum value, and we will try to find out the subtraction. Remember the subtraction operation that I was talking about? It is exactly that. Okay, by doing the subtraction operation, we will try to find out whether I can find this temp value, right? We will always try to find out that if I don't, here I'm doing the find operation, whether I can find that temp value. If I don't find, look, this line, this if condition is actually referring if I don't find that value. Okay, so if I don't find that value, I will just keep a track on fl equal to 0 and then break, because I cannot throw out all the elements if I cannot find that temp inside doing my operations, and I'm gonna be breaking out the loop. But if I somehow find out, let's say I find out, then what I have to do is I have to erase it from, first of all I have to erase it from my multiset. Also I have to erase the last element, which is the bigger one, also from multiset, and also I have to make sure that my new x is assigned, and it will always be assigned to what? The last element. Before erasing, I actually am gonna do this part, assigning the new x each time that I'm gonna be traversing, right? And finally doing everything here. This part is if I somehow find out that yes, I can throw out all the elements, then I'm gonna do break to find out, and each time I have to check this, I have to clear my set, and I have to set I mean by multi-set, and also the vector, because each time I'm just repeating and repeating and repeating till I fulfill and traverse n-1 steps, the rest of the n-1 steps actually, because the nth step I also already did here first in this line. So finally we'll just print the answer, and that's how we're going to be doing this problem. I hope it made you understand that, and sorry for the background music, and uh, actually it was an annoying sound outside of my house. I don't know where it's coming from. Sorry for that, and till next time, goodbye. Okay.